So, what's new in Symfony 5.1? We've just been through this. My name is Petersen. I'm a software developer at SensioLabs. I have been for the past 2 years here in Berlin, and I'm basically, I basically have the same username almost everywhere on the internet, Pete16. You can find me on Twitter, on GitHub, and so on and so forth under that name. Symfony 5.1, what's the status? So Symfony 5.1 is currently still in development. The release is scheduled for the end of this month. And since it's not an LTS version, official support for it ends in January 2021. And if you're new to Symfony, and you may think to yourself, well, that's actually not a lot of time. It's only 7 months. I better stick to the LTS version. For the LTS versions, we have 3 years of support where we fix bugs and 4 years of security fixes. So at first thought, that actually sounds like a pretty good idea. But actually, we do implore people to keep up with the latest release instead. And the reason for that is that Symfony tries really, really hard to maintain backward compatibility at all times between minor versions. And so new versions are actually added in the minor releases. And those like old APIs or old ways of doing things get marked as deprecated. And you will see those deprecations in your application logs. You will see them when you run your tests. And that gives you enough time to actually fix them. You don't have to fix them right away since they still work, but you should fix them in time. And the major version jumps, so like from a 3.4 to 4.0 or from 4.4 to 5.0 basically only remove deprecated APIs. So Symfony 5.0 is basically the same as Symfony 4.4, just without all the deprecations. And that's why if you keep up with the latest releases, if you have a solid test suite that sort of gives you some degree of confidence that if you do upgrade, that nothing breaks, there really is no benefit to staying with the LTS releases. And you get the latest features that Symfony has to offer, which is really nice. Anyway, yeah, speaking of deprecations, let's move on to the deprecations, or actually deprecation. There's only one major deprecation in Symfony 5.1, which is the Inflector component. So for those of you who don't know, the Inflector is a nifty little component that basically translates, if you give it an English noun in a singular form, it can give you the plural version of that. And it can also do it backwards. So you can give it the plural version of a noun and you can get back a singular version. It basically follows a bunch of heuristics that work well most of the time. And it's certainly good enough for most people's purposes. And this functionality has been moved to the string component. And the reason for that is, well, if you're singularizing words or pluralizing verbs, you're basically just manipulating strings. And so it makes a lot more sense to put that in the string component as opposed to its own independent component. And also the Inflector component only supports English. Now, obviously, there are a lot more languages than just English. And this English inflector over here, I don't know if you can see my mouse cursor, but the English inflector over here actually implements a common interface that all inflectors share, or all inflectors should share, which is the inflector interface over here. And the idea behind that is that perhaps in the future we could have maybe a French inflector or a German inflector, and so on and so forth. And that just makes it a lot more flexible and just offers people so much more possibilities. And that was the only deprecation. So let's move on to the new features. I just want to note that this is not a complete list. There are a lot of changes. So I basically picked out those ones that I think will be relevant for most people. And yeah, without further ado, let's begin. So we're going to start off with the new component, which is the Uid component. And this component, when the pull request was opened, actually sparked quite a bit of debate whether Symfony should try to cover everything under the sun, or whether Symfony should really focus on a small but core set of components. And I just want to note that this is actually not a complete replacement for Ramsey UID. So Ramsey UID is a fantastic library. It can do a lot, actually. It's really great. If you don't need most of the advanced features, if you just need to generate UIDs and you want to interact with them, then maybe, just maybe, you don't actually need Ramsey. Maybe you could use the Symfony UID component as well. And it's separate, and this component supports all versions of UID, so from 1 to 6, basically, and also supports ULIDs, which is basically the same thing as UIDs, but just lexicographically sortable. And so that's how you generate UIDs, and you can interact with them. There is also an object to represent the non-existence of a UID, which is the nil UID over here. And it's a relatively bare bones. You can instantiate a UID object if given a string. You can convert to binary, base 32, and so on and so forth. Moving on, I'm sure most of you have heard of async AWS by this point. It's basically an unofficial SDK for AWS. Because the official SDK is complete and everything, it's great, but the calls that it makes are actually blocking. And this unofficial SDK is asynchronous by default. It uses the Symfony HTTP client in the background. And now, starting from Symfony 5.1, Symfony will automatically use it by default if it's installed. So as we're going to see just in just a moment, there are a bunch of new and improved integrations for different components in 5.1, and the async AWS package for SQS will actually be used in one of them by default if this package is installed. A new and improved integrations by various contributors. We have support for MongoDB as a store for the lock, and also we have a new adapter for Couchbase and the cache component. You can use the sodium marshaller to actually encrypt your cache items, and the array cache has been extended and now has support for least recently used. So essentially you can set, the array cache, you can set a maximum number of items that can be contained in that cache pool. And as soon as it reaches that limit and you want to add something else, it's going to remove the item that you least recently used, because chances are that's the item that you're probably not going to need anytime soon. So that's quite useful, especially for computation. Mailer now has improved Mailgun integration, so you can set custom headers there as well now. For the Symfony Messenger, we have support for AWS SQS. And if you install the async AWS library, as just mentioned, it'll automatically use that. There's also support for Postgres as a messenger as a messenger backend, which uses the listen and notify functionality of Postgres. And there's also improved integration with Redis. And with the notifier, which is one of the newer components, we have a lot of new integrations here. We have Mattermost, RocketChat, Firebase for push notifications, and Cinch and FreeMobile, and OVH Cloud for sending SMS. So thank you to all the various contributors. You guys are awesome. It's great to see a lot of activity going on, and it's great to have all these great features and integrations. Moving on to the service container. This is also a relatively controversial one. We now have support for typed properties in a property info, which actually forms the basis of the next new feature. So say, for example, you have this example class over here, some class, and you have a public, you have a private Boolean over here called log result. If you use the property info component, you can actually fetch information about that property, and it actually tells you, yep, it's a Boolean and it is nullable. And this is basically the prerequisite for this next one. Auto-wiring publicly typed properties. So basically this is like setter injection without the setter. I think it's the best way to describe it. This was a controversial one. A lot of people mentioned that, yeah, it's bad practice. We shouldn't be encouraging that. I mean, at the end of the day, we do have setter injection. At the end of the day, we still discourage people from using that if possible. There are situations, I will say there are situations where it actually makes sense to use setter injection. There are just very few. If we have setter injection, on one hand, we might as well implement injecting dependencies via public properties, and also it's not really we shouldn't really be in a position to say you can do this, you're not allowed to do this, or whatever. I think that's a choice that people have to make themselves, and we should be giving them that possibility if they want to do so. But yeah, if possible, stick to constructor injection. It's always the better choice, or it's almost always the better choice. Speaking of services, we can also now, it's a lot easier now to define decorators in your service configuration. So the only change here basically is that instead of having to put the fully qualified class name as the first argument, when you're decorating a service, you only have to put the symbol, and it's automatically understood that you're talking about the class that you're decorating. And what's also related to that is the situation where if you have one class and you want to decorate it, but you have multiple classes that you want to use, And in this case, before you would basically, I just have to specify it using the old syntax. And in this case, it's not inherently clear which service is the outermost, like which service forms the outermost layer, if you know what I mean. So if you basically have configured the mailer service in such a way, does the rate limited mailer come first, or does the logging mailer come first? Obviously, the last service that's defined comes first, but it's not inherently clear. And with this new stat decorators, you actually have a list of decorators that you're using and exactly in what order that they're being used. So you have the logging mailer first, and then comes the rate limited mailer, and then comes the actual mailer service that's being decorated. Another great one. This was something that used to confuse me a lot when I first started with Symfony. But when I first started working with Symfony, was that you would have these service definitions, and you'd specify an argument, but you'd leave it null. And you'd have a comment. If you're lucky, you would have a comment, oh, this is actually defined in this compiler pass or in this extension or whatever. With Symfony 5.1, you have the possibility of declaring that an abstract, an abstract dependency, an abstract argument, basically. What this basically does is that if for some reason you do forget, or if your extension or your compiler pass is buggy and doesn't actually define what this argument should be, it's going to give you an exception that is a lot more readable, because it'll actually put this text here defined right beside the abstract. It'll actually put that in the exception message. And so you can have a lot easier time debugging that if you do run into that situation. This is a feature that will help, especially with older code bases. When Symfony first came out in the first few versions, basically all of the services in the service container were all public, and you would usually access services via the container. And so in recent versions, we've decided to, we've started to transition away from that, and try to encourage people to inject their dependencies, to not have their services depend on any container. But in a lot of older code bases, it takes quite a lot of time for that transition to be done. And with Symfony 5.1, we now have the opportunity to actually mark, to actually sort of add deprecation notices for public services. So if you want to make this foo service private in the near future, or if you are a maintainer of a library or a package, and you actually want to mark that service as private, but you don't want to break BC compatibility, then you can use this tag. And what this does basically is that if the container is used to access this foo service, it'll actually result in a deprecation notice. And so it's the same kind of deprecation notice like you'd see with Symfony, and that gives users enough time beforehand to change their code. Right, moving on to routing. So with routing, there are a couple of other changes as well. We now have the ability to specify hosts per locale. So for a while now, we've had the ability to basically specify a host for a specific route. But now you can actually tell the route, okay, if the locale is French, it should be this domain. If the locale is English, it should be this other domain. What's important to mention here is that you really need to make sure that all the locales you use in your application are defined here as well in this list. Because say, for example, if you use German, French, and English, and you don't list German over here, it's actually going to cause an exception. Obviously, because a web application needs to know, or it needs to be available under a domain. And if you don't specify that, it will definitely let you know. Another change that has come with Symfony 5.1 is a simpler way to define a request context. So this is something you don't usually need for the web side of Symfony, but if you're writing a console command that generates absolute URLs, for example, the console command itself doesn't exactly know under what a domain it's available on because it's not running on a domain per se. But you can specify a kind of default route path and a default host and default scheme. And before you would do that via parameters, and you would simply rely on the fact that Symfony reads the parameters with this specific name. And now you can specify that as a configuration setting on the framework bundle. So that's pretty nice. Another thing is route annotations priority. So when Symfony tries to figure out which route which route should handle an incoming request, it basically goes from top to bottom. And so if you didn't have this priority equals 10 down here, you would never, ever be able to access foo because it would basically be caught by some parameter all the time. And with this, you're able to specify a priority so that when Symfony is looking for routes to handle a request, it's gonna look at foo first, and then it's gonna let foo access the incoming request. Another cool new feature, stateless routes, gives you the ability to basically explicitly mark a route as not using the session at all. So if you want to make sure that a route does not access the session in any way, shape, or form, you can set it. You can set stateless to true, and if the session is ever accessed or changed, modified, whatever, then it's going to throw an exception. Or it's going to throw an exception in development. Obviously, in production, it won't. Or if debug is set to false, I mean, it won't. If debug is set to true, it will. If debug is set to false, it'll just output a log message. Another cool feature, but a lesser known feature about routes is that you can basically have the route basically execute any, pretty much any kind of logic when deciding if the incoming request should be handled by it or not. So obviously the most obvious thing that you use to match is the path, obviously. If the path matches, then the route will handle the incoming request, but you can also set a condition. You can also set the scheme and host. And with the condition, you're now able to access environment variables. So this is basically a very primitive implementation of a feature flag. It looks primitive, but I think for most use cases, it'll actually be enough. So that's pretty cool to know that that's possible. Moving on to the validator, we have quite a few new validation constraints. Starting off with the fact that you're now able to basically bundle up a bunch of validation assertions uh, this is most useful. I think the quintessential example is the password. So on a website, you usually have multiple things that a password should have. So it should have at least one number, should not be blank, should have a minimum length of whatever. And instead of having to basically retype that every single time you want to validate an object with a password property, you can basically group all of these constraints into one, and you can use this as an annotation on um, on the property of your choice, and um, it'll basically act as if you had just written these 4 lines right here. So that's pretty cool. There is another one that's slightly related, but not exactly the same, which is sequentially, which is also a grouping of validation assertions, but it doesn't run all of these validation assertions all at once. Instead, it looks at the first one, so in this case, type. And if it fails this assertion, so if it's not a string, it basically returns right away. If it passes type string, then it goes down to length min4, and then goes down to regex, and then goes down to this custom constraint. And this is pretty useful if you have validation constraints that take up a lot of resources, and you don't want to waste those resources if the others don't pass. So that's pretty cool. There's also the at least one of validator, which does what it says on the tin. It takes a group of validation assertions and it'll pass if at least one of them is true. The hostname validator also does what it says on the TIM. It validates host names. And yeah. Now moving on to security, quite a few interesting changes here as well. For a while now, there's been an ongoing effort to simplify the security component because it's quite complex and there are definitely things that could be done differently. And so a small step in that direction is with this little change over here. So we all know about the security attributes is authenticated, remembered, anonymously, and fully. And if you wanted to check that a user is logged in, but not logged in fully, you'd have to keep in mind that is authenticated remembered returns true for those that are logged in because of remember me, and also for those who just logged in. So that's a little bit tricky, and you would actually have to do this is granted, is authenticated remembered, and not is authenticated fully if you wanted that information. And that's been simplified a little bit. We now have is remembered, which basically only returns true if you are logged in because of remember me. We have is anonymous, that returns true if you are anonymous, and is impersonator, which is basically just a rename of role previous admin. Why was it called role previous admin? I have no idea, but I do not. But I now know that it has a much better name. And with the Symfony security component, we have 3 so-called access decision strategies that basically control how the response of the voters actually influence a decision. And there are 3. So there's affirmative, there is I forgot the other 2, but I know that one is democracy. I keep forgetting that. I think it's consensus. And now we have a 4th one, which is priority. And this has a lot to do with, so with voters, you actually have the possibility, you've had the possibility for quite some time to specify a priority in the service definition. But realistically speaking, with these access decision strategies, you don't that priority doesn't really play much of a role, if at all, because it doesn't basically just look at the first one and then decides based on that, but it goes through every single one and decides to allow the action if at least one voter said yes, or if there were no voters that denied it or something like that. And this access decision strategy basically goes through each voter one by one. It takes the priority into consideration. And the first voter that doesn't abstain, that either returns yes, we'll allow that action, or no, we will not allow that action, that's going to be the final decision. And so it's pretty useful in those cases where you want sort of individual voters to have more influence on the decision making at the end. Now it's going to be a lot easier to customize how your application behaves on logout, because there's a new logout event that's thrown or it's dispatched rather when a customer logs out, or when a user logs out, sorry. And you can use an event subscriber for this, obviously. It's just a normal event, just like any other. Realistically speaking, though, I think most people are probably going to end up using an event listener, simply because you can also specify which firewall or which dispatcher you want that event to be coming from. So you would usually be listening on logout events for a specific firewall only. And in that case, you can only do that with the event listener. With the event subscriber, you're just listening to every single logout event. That's probably not what you want. So this next section is just titled Micro Applications. This is not a term found in the Symfony documentation, but it's just a nifty term, I guess, for the next two improvements. So we now have an improved microkernel, which basically lets you define like a full-blown Symfony application in one file. And well, first of all, you may ask yourself, well, why would I actually need that? And there are certain use cases for that. Like one use case that comes to my mind, at least, is I was working on a bundle for TurboLinks a couple of months back. And so basically TurboLinks, for those of you who don't know, it's a JavaScript library that was first released with Ruby on Rails. And essentially what it does is that it hijacks clicks and it sends AJAX requests instead. So instead of fully loading the page again and fully loading all assets again, it hijacks a click. It sends an AJAX request for that route as well. It extracts the body and just replaces the body. So you basically can browse through pages without actually reloading the entire page, which is pretty cool. And that, it has a few, it is a little bit tricky in some edge cases, and I didn't want to basically mock everything out because it just felt wrong. It didn't feel like I was actually testing the thing. It felt like I was testing my mocks. So I decided to basically use a full-blown Symfony application in my test, and just treat that kernel as a black box and just be like, hey, I'm going to send this request, basically trying to simulate what TurboLinks would send and see what I get. And this is something that would really help in that respect. But I'm sure there are a number of other use cases. You would treat it like any other kernel, basically instantiate it as normal, call app handle, send a response, and terminate the kernel. So apart from this setup over here, it functions exactly like a normal Symfony kernel. Moving on, we have the single command applications, which is pretty useful if you're using the console component in a standalone fashion and you don't need to like define multiple commands. If your executable only does one thing, then there's really no need to define multiple commands. And this lets you do it in an easy fashion. You have these setters here that you know and love from the command parent class. And you can do all the things that you're used to here as well. You just have the set code over here, which basically takes in a closure, which is basically the same thing as the method that you overwrite when you're inheriting from the command class. Okay, we have two more changes that sort of don't fit in either category. So we're just gonna go over them really quickly. We have configurable PHP preloading. So PHP preloading is one of those features that's been widely touted. It's awesome. It just leads to so many performance benefits. This feature gives you a lot more flexibility in which classes get preloaded and which classes don't. So you can specify, so for any given service, you can specify which classes should be preloaded. And I didn't actually add it here, but you can also specify which classes should not be preloaded. So that's pretty cool. It gives you more control over that. And if you know that you have a specific dependency that is heavy and you don't want to have to reload it on every request, then you can certainly use this and it'll help you a lot in that respect. Another really cool thing is simpler login in tests. So with tests using the this Symfony test client, you either, if you want to log in the past, you would either have to simulate a login, so actually use the DOM crawler and actually send your credentials to the login path. That's one option, but it's a little slow if you have to do that every single time. So another alternative that was actually documented in the doc for a really long time is to specify a special firewall only used on the test environment and basically craft your authentication token yourself. And that led to some really fast speed when calling login a lot of times, but also it felt really awkward because that's a pretty common use case. So now it's a lot easier. We now have the login method on the client itself, and it does what it says on the tin. It logs the user in, and it's pretty, yeah, it's a lot easier to read and easier to use than defining a custom firewall for the test environment. And that was it. Thank you all. Thank you all for watching. More importantly, though, thank you to everybody who has either contributed to Symfony or helps out the Symfony community in lots of ways. Perhaps you go on Stack Overflow and answer a bunch of Symfony questions. I know at least one person that does, it's just so awesome to, it's a privilege for me to work at SensioLabs and to work with people that basically make this framework and the software ecosystem basically great. So big thank you to everybody who's either worked on the code or on the docs or just helped to promote Symfony. A big thank you from the bottom of my heart.
And yeah, getting started with mutation testing. Just to be upfront with you, I basically looked at Inflection, the mutation testing framework I'm going to tell you about, on 2 weekends before doing this talk. So I'm no expert, but at the same time, I think it speaks volumes that you can basically just get into it so fast that you basically can already tell people like, oh yeah, this is great, and this is how you use it. Just very fast. And I've just figured it's a useful tool. I really liked using it and introducing it to a test project. And I know there are quite a few talks out there that talk about infection and mutation testing since I think mid of last year. So if you maybe go to a conference and catch one, it might be great to get more info. And yeah, so it's basically not a new topic, but it's one that is recently got more traction and basically gained popularity. You basically got the introduction already a few times. So my name is Denis. I work at SensioLabs Germany, and I mostly do migration projects. So if you have an old legacy project in an obscure old framework that maybe you wrote yourself and you figured, no, we don't want to use that anymore, we want to use Symfony, then you basically can call us if you're in the German speaking area in the DACH realm. And yeah, maybe I can work on your project and help you slowly migrate away from that old framework and to a nice new Symfony project. But I also do other stuff like these talks. And I already mentioned infection. So this is basically what the whole talk is about, the mutation testing framework. You might also know Humbug. It's the predecessor of infection. And if you haven't used it and you maybe just heard of it, you might wonder what is this kind of mutation testing? And what it involves is just changing your program, which just sounds weird and scary if you hear it, in very small controllable ways. And then it checks if your test catches those changes to your code. And basically, if you have a test for that code and you change it and your test doesn't break, then obviously your test misses some behavior that could change at any point without you noticing, and it may be a bug or a side effect that you introduced, and so it will catch it early for you. And to get you started really quick, what do you need to get infection running? You need PHP, you need a testing framework like PHP Unit, PHP Spec, or Codeception. I think those three are supported right now. I only used it with PHP Unit so far. And then because it works on the covered code that are covered per tests, you also need something to enable code coverage, which is usually Xdebug or PHP debug or pconf. And basically that is it. That are the prerequisites for mutation testing with infection. And then you can install infection in many ways. You have a file archive that you can download and basically install globally, like you, for example, can do with Composer. You can also use Pipe, which is a package management thing around FAR. And you can also just install it with Composer using infection, either globally or inside your project. And I highlighted the FAR archive because that is the suggested way, but I usually use the Composer method when using it. And one of the cool things that makes getting into mutation testing and infection really fun and fast is that once you install it and you run it, you can see the vendor bin infection here, then it will notice that you don't have a setup file, a config JSON for infection. So it will guide you through the setup project and set up this configuration file for you. And it will do it in a very nice way where it first asks you which directory is the one that is containing the code that we want to test. And if it sees that you have a source directory, it will basically tell you, yeah, should I pick this one? So it will also give you nice defaults. You can start excluding certain files if you already know, like in a Symfony project, I have the kernel PHP in my source directory, and I don't really care about that. I can just exclude it, by the way. And the cool thing is, if you don't have PHP unit set up for whatever reason, it will even notice that and tell you, yeah, I actually need a testing tool that I run in, or that I run for you. And so it will basically tell you, no, you don't have that set up, help me. But if it's already there, then it will just recognize your PHP unit XML. It will recognize where your PHP unit is, for example, in your Composer thing, in your vendor directory, and you're ready to go, and it will create a config file for you, and you're ready to get started, and we'll do the first one. And that is really easy and fast. And I figured just to give you a glimpse on how it actually looks when we run it, I will just show you a demo project. This one is not a Symfony project. It's basically just a source directory of one file and a test directory. And you can see that the composer JSON is very uninteresting. I only have my testing tool here and infection. As I said, I just use it with composer require and then --dev. And after setting everything up, I get this infection JSON dist. This is the configuration file that was created for me. And let me just quickly delete that and maybe run the command line, and I will make this a little bit bigger. So now you can see the same setup process again. You can see that if I just do nothing, it will pick the source directory. I can exclude certain files, and it asks me where to store the infection log file. You can see that I put it in var cache log before. So let me just use that directory. If not, it will just put it in root directory. And now it created the file, and it directly starts running the tests, which is pretty cool. Like, you don't have to go through many hoops to get it started. It's already working, and you can already see that I see some coverage scores here. I will talk about those in a little bit. Maybe let's first start looking at the code itself that we run this thing on. So what I have here is a countdown class that is kind of artificial. I basically specify a time when this countdown is finished, constructing the class. And then at any point in time, I can call the get method, and it basically tells me how close we are to this countdown time. And I don't have any proper error handling, like what if I exceed that time, that it goes in the negative or anything like that. And the only thing I do is to basically ask, is this finished? I check if the time is greater than finish at. I use Unix timestamps here. And so it's a very basic class. It has a constructor, it has a get method, which basically gives me the current countdown, and then is finished method that tells me the countdown is finished. We are in the negative right now. And my test is just as simple, if not even simpler. What I do is I create my countdown for 10 seconds in the future. And if I instantly get a countdown get, then I should get 10 back, because I have the difference of 10 seconds. Timing test is always a little bit tricky, but for the sake of our example, this is fine enough. And the same for, is the test finished? I specify negative values, so sometime 10 seconds in the past. And now it should tell me that it's already finished because we are in the past. And now I can run this test with PHP Unit. And you can see the test passes. And you can already see that I created a coverage report here, and I hope it's for this file. I have one class with 3 methods, and yeah, that sounds about right. And here you can see that I have a coverage summary from PHP Unit, which is class coverage, method coverage, and line coverage. And then with infection log, oh, this is from the second example. So why didn't it override the one before? Let me run infection again. So here you can see we have coverage as well, and those are different kinds of coverages. And this is where the mutation testing and where infection is basically interesting. If you're interested in coverage, and you're basically interested in coverage for making your code better and not just having it as a metric where I strive for 100% line coverage just so I can say I have my 100% coverage, which can seem odd. You might think, like, if I have my 100% line coverage, then obviously my code is well tested because I have a lot of coverage. And to a certain degree, that is true. If I have lots of coverage, then I covered lots of cases. But it's not necessarily true that I covered everything that is valuable to me and all the cases that I want to cover. And so basically, the line coverage tells you how many lines of my code have I covered by going through it using the test. And it doesn't necessarily say how many lines are covered. It actually says how many lines are executed. And you can see this if you, oh no, those are different examples. You can see this if you have the HTML coverage report. You can actually see like the legend says it's executed code. It's not tested code coverage. And so basically there can be cases where you ran over the code, but in that line, you have certain conditions that you haven't tested for. And the mutation coverage tries to identify those special cases where, for example, we haven't tested what happens if this is smaller than instead of bigger than, or if it's equal than. And what happens if we add, for example, instead of subtract here. And this is what the mutation coverage and the covered mutation code basically tells you. And it tells you in a really neat way by, it still has the Fibonacci stuff in there. So let's maybe just use hashtag. Oh, I put it there. Thanks for telling me. So yeah, so this is our example. And here you can basically see what infection does and how it tells you that, yeah, you may have this line covered, but you have not covered all cases on this line by telling me, I ran a mutator called the greater than mutator on this part of your code. This is what I changed. And it basically tells me by telling me this is an escape mutants, you somehow did not write a test that covers this scenario where the time is not just greater than, but greater equal than. And you also have this example where you did not cover what happens if you run into this exception case. Your code could behave differently if someone accidentally changes something. You did not catch it, your tests will not break. And so you might introduce weird behavior. And this is basically a way to give you more than just, oh, this line is covered. It actually tells you those are the cases on that line that are covered, if that makes sense. And with those Fibonacci example that you could already see because I messed up with the cache directory thing. So if you look at this, I basically have a class that does Fibonacci, hopefully right, I think. And you can see because I used the ternary syntax here and I basically try to compress everything in one line, that there are quite a few cases that you could cover, and just pure line coverage will basically not tell you much. You can get a 100% coverage and it will still not be. Oh wait, I don't have to run the coverage thing because I can already show you. So this is my PHP unit coverage. I have one test that basically checks if I run this for the number one, then one comes out, and I didn't test all the other cases. And you can see the code coverage, the line coverage tells me, yeah, I executed this line, everything is fine. But if I look at the infection thing, it will run again. It will actually catch quite a few mutants and things that are not covered, that are not escaped. Here you can see covered mutants were not detected, 11. And there were 4 errors encountered by mutating the code. And you can see that my code coverage when it comes to the mutation score indicator is actually not that great. And there are a few cases that I missed. And basically by giving you the report with all the different cases that it ran, it also gives you a way of, this is what you should change. So if you look at this log, for example, I can add numbers. I can can decrement integers instead of 0. I can produce -1 because I didn't test what happens if I put in 0 instead of 1. I also 0 integer. There's a change here. Oh yeah, it made the 0 into 1. So again, the same classifier. It's basically the same test case that I didn't encounter for because I didn't test for the 0. So what I can do now is I can improve my test. I know which case was not well covered, and I call it test Fibonacci with 0. And instead of running it with 1, I just run it with 0. And I will run infection again. And hopefully now there at least the code already improved. And let me look at this log again, because probably this is where we write it now. Yeah. And you can see that there's still a few things that are wrong, but by giving me something, not just the line that was covered, but actually this is the change I made, and it went through, and I didn't expect it to go through. It will basically guide you to what kind of test you should write and what behavior you should basically cover with another test so that it works well, if that makes sense. And you can see that it's really easy to set up. So you already have everything in place to get this running and to introduce it in your test suite. And I think we already talked about the coverage thing. And just a disclaimer, and to be fair to PHP Unit and line coverage, you can actually make line coverage better by basically making sure that certain parts of the code that you want to ignore, you can do code coverage ignore, for example. And you can also have your tests say, this test explicitly only covers this class. So if some other code is executed by having, for example, dependency like this money object, then it will still only cover invoice and not cover this code. So the line coverage will still tell you still have to test money, but it will still just be line coverage. It can make your coverage score more honest, but there's still a few things that it will not catch, which infection will get for you. So I already mentioned that there are these mutators that change your code in a certain way, and it basically does those changes in a controlled way because we don't want to produce syntax errors, for example. We don't want to have some weird change that is just a formality thing where we have, for example, a string and we just replace things in that string, and it would just be basically, oh yeah, I didn't test for the exact value. There's a certain class of change that you want to have. And the other thing is that the more mutators you run, then the more your class has to potentially be changed, which makes the mutation testing considerably slower. I will have another example for that later. So what infection does is it has a list of mutators that, first of all, it enables by default, and some more that you can optionally enable by running a profile or by enabling those mutators. And it has a great documentation of what mutators there are and what kind of code change they introduce. For example, there's this Boolean substitution that replaces a true with a false, for example, in your code, or minus with a plus, the $end, double end to the double pipe thing for logical AND and logical OR. It can also replace the numbers. We saw this with, for example, the Fibonacci thing where we had 0 and it replaced it with 1. And it also did a decrement with -1. And I think there's also explicit 0, 1, 0 negative, thing. So we don't have to go through the full list, but there's basically a set list of changes that infection will do. And the good thing is, it's not just very basic stuff. It's also more advanced thing, like we saw the throw thing as well. And the good thing is that you have full control over which mutators you want to enable and disable, and you can also exclude certain files if certain mutations make no sense on that file, for example. So if you basically encounter something where you say, I have this mutation that always gives me a false positive, it tells me you have to cover this, but it doesn't really make sense for me to cover this, then you can basically disable this mutator and ignore it for you, or you can just do it in certain files. So just to give you a sense why this is important, I have this library here called Rich Model Forms Bundle. It's bundle that you can download, and it has a fairly small test suite. It's 77 tests. It ran in 1 second. And when I do the same thing with infection, and hopefully this still works, then you can see it collects all the tests. It generates the mutants for all those tests. And you can already see that it's considerably slower. One cool side effect of this, getting all your existing tests and the code and checking which things to mutate, which code to modify, that it basically fans out your testing. It creates tests for those mutated classes. And that is what makes it slower. Obviously, you can see it's instead of 77 tests, it's 288. But the other cool side effect is it will also randomize your tests. So in case you have tests that maybe rely on a certain order they run in, you can actually catch this with mutation testing as well. And you can already see while this thing runs in still considerably more than 1 second that there are a few escape mutants. But you can see without having run this on this project before and having looked at it, it's still a fairly decent coverage score. It's 88%. And I can now basically look at my log and basically go into this library and check if I could make the test coverage even better, or maybe see if things are not covered. But the main point here is instead of 1 second, it ran in 1 minute. And it's not that if it ran in 2 seconds test suite, then it will be 2 minutes. It will actually increase quite a lot. So I saw a talk where someone ran it on Symfony, and they said it will take over 50 hours, which is probably not something that you want to do. So if you introduce it to a project, what you probably want to do is you want to improve performance. And one way you can do that is by changing the mutators. I already mentioned that. You can also, if you run infection in the CI pipeline, you can run it on only the changed code. This is from the infection documentation, so you can copy it from there. It basically collect all changed files. It will only look at the added or modified files. It will ignore the removed files. And then this filter is passed to infection, and then it will only look at those files. Another thing to improve performance is by running it in multiple threads. For unit tests, that should be safe, and all the unit tests I ran it on, it worked fine. But if you have something like functional tests, you might run into issues there. Also, just generally running it on higher level tests, mutation testing can get a little bit wacky there because it changes the code and it mutates stuff. And it's on such a huge scale. When you run, for example, web test case, it can have weird side effects. Whenever the team notices something like that, they can address and they can fix, they actually do that. But that's a small caveat. Mutation testing is basically well suited for unit tests, but not as well suited for functional tests, but it might work. Another thing to improve performance is to only look at the code that is covered by tests, because if you have uncovered code, then you can change it all you want. It's already uncovered. You will already have cases that you basically don't know how the code behaves. And so there's no point in running the tests there. So actually, this probably should be your default. especially you don't have like 100% coverage of your code, and it will make things faster, and you will not really have a downside as far as I can tell. But again, I only ran it a few times. And as I already mentioned, you can also disable filters, and you just say, I don't want to use this filter because it doesn't make sense for me. And that should also considerably increase performance. And yeah, basically that's it. You can get started with Infection right away. And just to give you a small summary of what is this thing good for, and should I use it? One of the major pros of Infection is how easy it is to set up. You basically do a composer require, you run this setup tool which guides you through everything, and it will just run with your existing test suite. A small thing that I didn't mention, your test suite actually has to pass. If your test suite errors out, then basically Infection cannot do anything with that because it needs a successful test suite. You can pass in options to ignore certain tests, for example, if you have those in your test suite. I didn't go into that, but just if you have a new project, you want to use it, or you have a test suite that works fine, then it's super easy to get started and see first results in your Infection log. And another pro is that basically by having this Infection log that tells you which changes the mutator did, you can easily spot what kind of tests you have to write to basically stop this behavior from being uncovered. So it's very helpful to guide you what kind of test you have to write if you're not quite sure. So I think it can actually be a really cool tool if you're not too familiar with testing yet, to basically start with writing a few tests and trying it out with just PHP Unit, and then looking at the mutations that Infection log tells you to basically see, oh yeah, those are tests that I should write. So I actually think that it might help you if you're not very safe with unit testing with PHP Unit. The downside to that is that because those mutators can actually tell you to change things which don't make much sense, it gives you false positives. It's very upfront. It will always tell you like, oh yeah, there can be false positives. But if you're not too familiar, then it might be hard to spot, is this a false positive or is this something I should test? But in general, I think it's really cool to have this guiding information there. And yeah, one thing that I already mentioned, it gives you a kind of better coverage in air quotes. It's basically a more in-depth coverage than just line coverage. It doesn't replace it, but it gives you another cool thing on top that will basically tell you the line coverage is not enough to go here. And the cool thing is you can hook it in CI. You can actually use existing coverage reports to speed up your testing. So if you already ran a PHP unit with coverage, you can use this coverage to basically tell Infection what to look out for and what to build the mutations on which covered code. And so that's really useful you can hook it in your pipeline. You can use it with GitHub Actions or with Travis CI, for example, or you can, if you like, put it in a Git hook, for example. So it's really easy to have it running all of the time. The downside to that is that it's slow. So commit hook, probably not the best place to put it, but as I mentioned, there are a few things where you can speed it up. It will still be slow, but if you run it on certain branches, for example, I think the benefit outweighs those cons tremendously. So, and that's it for my talk.